Hello everyone, my name is Kunhao Wang. I'm a master student of computer science. In this video, I would like to talk about my master thesis, and the topic is bridging SysML and SysML v2 by using language aggregation. Systems modeling language, in short, SysML, is based on a unified modeling language, and the format of the modeling is mainly graphical based. Systems modeling language v2 is newly introduced by Object Management Group. It is based on kernel modeling language. The format of the modeling is mainly textual-based. Even they are both used in model-based system engineering, but there is a technological gap between them. The models written in SysML cannot be directly reused in SysML v2, and vice versa. In this series, we are trying to use language aggregation to bridge this technological gap. We use the magic draw as the SysML side and the multi-core as the SysML v2 side. The goal of our thesis is to make the models reusable on both sides. Language aggregation is one of the ways to compose multiple languages in a loosely coupled way to describe a target domain. In our case, the domain of system engineering. The models are created and processed independently and remain in individual artifacts. A model refers to the elements in other models by their names. Symbols are most essential part for the models. The symbol table is used for quick navigation and cross-referencing of the symbols. Symbols can be reused in different models. For example, the block symbol fuel tank in a SysML model is reused in a SysML v2 model, indicating there is a part property with the type of fuel tank. To achieve this, we can aggregate the symbol table of different models through language aggregation. SysML and SysML v2 are two different languages because they are based on different metamodels. However, since they are both used in model-based system engineering, they share similar concepts in some symbol counts. For example, SysML uses a block symbol to model a system or system component. In SysML v2, they are using part-defined symbol to model a system or system component. In the upper picture, we have a SysML model. There is a block symbol named laptop that is used to model a laptop system. In the lower picture, there is a SysML v2 model that has a part-defined symbol called laptop used to model a laptop system. Based on this feature, we can introduce language aggregation for reusing symbols in different languages, such as reusing block symbol in SysML v2 and reusing the part-defined symbol in SysML. To do this, we first need to create a symbol mapping between these two languages. Here is our toolchain for creating symbol mapping between SysML and SysML v2. A symbol must have a unique name for reference. On the SysML side, not all SysML elements can be considered as symbols. For example, transitions and associations are usually not named during the modeling. Therefore, we do not consider them as SysML symbols. In other words, we only focus on the SysML elements that are definitely the named entity during the modeling. In order to chain, we first need to identify whether the SysML element is a SysML symbol. Then, we map the SysML element that we consider symbol to SysML symbol. Finally, we do the mapping between SysML symbols and SysML v2 symbols. After completing this toolchain, we obtain the mapping tables between SysML elements and SysML symbols, and a mapping table between SysML symbols and SysML v2 symbols. The left-hand side is a SysML model, and the right-hand side is a SysML v2 model. We illustrate the mapping concept based on these concrete examples. We have a SysML block element on the left-hand side, and since block is an essential element in SysML, and they are usually named during the modeling, therefore we introduce a SysML block symbol for it, which can be adapted to the SysML v2 part-defined symbol. Proxy port element is also an essential SysML element and is usually named. We introduce a SysML port symbol for it. Then we adapt this SysML port symbol to SysML v2 port usage symbol. In the following, we map the SysML part property element to the SysML part property symbol and adapt it to SysML v2 part property symbol. No SysML symbols is introduced for associations, since the associations are usually not named during the modeling, and also no mapping to SysML v2 symbol. Here is the implementation concept for the direction from SysML to SysML v2. After obtaining the mapping of the SysML elements to SysML symbols, we can based on this mapping to create the symbol table of a SysML model. The model elements are tree structured in the condiment tree of the magic draw. Therefore, we can select the root element of a model to traverse the other model elements in this model. We transitively traverse the model elements in this model and create the corresponding SysML symbol based on the SysML element according to the mapping table. After all symbols of the model elements are processed, the symbol table of this model is generated, which is in JSON format. In the following, we can load the SysML symbol table to SysML v2 side. We can then map the SysML symbols from the symbol table to SysML v2 symbols according to the mapping table, and reuse them in a SysML v2 model. In this direction, we design a multi-core grammar for the SysML symbols and implement a magic draw plugin integrated with this grammar to create the SysML symbols and export the symbol table of the SysML model. This toolchain describes the implementation concept for the direction from SysML v2 to SysML. Initially, we export the symbol table of a SysML v2 model from the SysML v2 side and import it to the SysML, in our case, the magic draw side. Afterwards, we traverse the symbol table and create the mapped SysML element based on this corresponding SysML symbol. Finally, we can reuse the mapped SysML v2 symbols on the SysML side. In this direction, we implement a magic draw plugin for importing and traversing the symbol table of the SysML v2 model. In the following, we show the demo. We first show the direction from SysML to SysML v2. Here is a SysML model called field system. We want to reuse the block symbol field tank to a SysML v2 model. For exporting the symbol table of this model, we right-click the root element of this model and select the derived symbol table, and select the path to save the symbol table. Give it a name, field system, and save. The symbol table is created. We can reuse this symbol table to a SysML v2 model. This is a SysML v2 model called a vehicle system. We can import the symbol table field system and set a new part property called the field tank. The type of this part property is field tank. We import from the SysML side. We need to set the symbol path to the global scope. The global scope will load the symbol table from this path. We put the symbol decer to the global scope. It maps the SysML symbol to SysML v2 symbol. Here we load the symbol table to the global scope. We resolve the part property field tank and get X tab and try to resolve the symbol of X tab. This symbol is from SysML side. We can resolve this symbol. It indicates that we can reuse the symbols from SysML model to SysML v2 side. For the direction from SysML v2 to SysML, we want to reuse this vehicle infotainment system to a SysML model. We first need to serialize the symbol table of this SysML v2 model. After serialization, we can get this symbol table in a JSON format. Then we can load the symbol table to a SysML model. The new SysML elements based on SysML v2 symbols are added. In the end, we are able to reuse symbols from SysML v2 to SysML side. Thanks for your watching. Hope you enjoyed this video.